Hey, today we're going to talk about 8.6 thermal pollution. So before we begin, you can check out the Enduring Understanding, look at the learning objective, pause the video, review the essential knowledge, and set up your Cornell notes. So remember that thermal refers to heat. And when we're talking about thermal pollution, we are really talking about, it's all related to dissolved oxygen in water. Recall from chemistry that all atoms above absolute zero are moving. Every single atom has some sort of energy in it. And colder atoms are moving slower, but when you heat them up, they move a lot faster. Now, when we're talking about oxygen molecules within water, oxygen is a diatomic. It's two O's, and it is nonpolar. It doesn't really mix well with water because water is polar, and opposites in this case are not good. Like dissolves like, so polar and ionic compounds dissolve really well in water, but not molecular nonpolar. Anyway, that was a little review for chemistry. However, you heat up oxygen, it's going to move faster, and oxygen does not dissolve that well in water anyway. So when you heat it up, these oxygen molecules are going to escape and enter the atmosphere. So it is very difficult to keep warm water very oxygen rich. And that is the big issue with thermal pollution. With thermal pollution in colder water, fish will have a lower metabolism, which means they will have lower rates of respiration and less oxygen. But when you heat them up, when you heat up the water, the fish have a higher metabolism. In order to maintain homeostasis, they have to have higher respiration, which requires more oxygen. And that's not necessarily possible in water with high temperatures. So fish and other aquatic organisms will undergo what is called thermal shock, and this can lead to death. So some of the sources of thermal pollution, most notably nuclear power plants, coal-fired power plants, storm runoff. Anytime you have warm pavement in like a summer rain, and you have a rain event on a really hot summer day and the pavement is super warm, that standing water that will be on the pavement, and when it washes into a body of water, it can cause thermal shock from the increased temperature. And also clear cutting near any aquatic ecosystem, so a lake, a river that normally had trees that provided some sort of shade with their canopy. Once you cut down those trees, you are opening up that body of water to all the solar radiation and all the infrared radiation that comes along with that. So I have a diagram here of a nuclear power plant, because nuclear power plants have a special need for even excess water because of their nuclear reactors that are happening in the containment structure. So they not only have to have water to convert to steam, they have to have additional water to cool down the control rods and the fuel rods. So one thing we have is this cooling tower. And cooling towers, you might not know how they really work, but what happens is you have this hot water and it goes into the cooling tower, and basically there's pipes that go up, and they have a giant fan. They have fans above it that basically they spray the water down, the hot water, and as it's like aerated, it cools off relatively rapidly, and the cool water collects at the bottom, or cooler water, I don't want to say it's cool, but it will be returned to a reservoir, a lake, a river, wherever they got the water for this reaction, or for this reactor. The same thing will happen in a coal-fired power plant. It's just that they don't need as much of the water to keep the system. They don't have a containment structure to worry about. But they still do, at a coal-fired power plant, produce steam. So there is need for a cooling tower. So let's take what we've learned and practice with an FRQ. I want you to explain how an aquatic ecosystem would be impacted by the generation of electricity at a nearby nuclear power plant. So, thank you very much for your attention. I hope this was informative for you. I will see you soon.